Hi, everyone. Welcome and good evening. My name is Benjamin Quinn, and on behalf of Harvard Bookstore, the Harvard University Division of Science, and the Harvard Library, I'm honored to introduce this virtual event with Stephon Alexander, presenting his new book, Fear of a Black Universe, An Outsider's Guide to the Future of Physics, in conversation with C. Brandon Ogbunu, with a special introduction by Harvard's own Greg Keston. I hope you're all well and safe. Thank you so much for joining us virtually. Tonight's event is the latest installment in our Harvard Science Book Talk series, which works to bring the authors of recently published science literature to our Cambridge community and beyond. Coming up in the series, Friday, October 29th at 6 p.m., we'll host celebrated neuroscientist and director of the Brain and Creativity Institute at the University of Southern California, Antonio Damasio, for his new book, Feeling and Knowing, Making Minds Conscious. To learn more about this and our other upcoming virtual events, you can visit harvard.com and sign up for our email newsletter, or check out the page harvard.com/science for more info. I'll also be posting a link to our Science Research Public Lectures YouTube channel in the chat, where you can view previous talks you might have missed. This evening's discussion will conclude with some time for your questions. If you have a question for our authors at any time during the talk tonight, click on the Q&A button at the bottom of the screen, and we'll get through as many as time allows. In the chat, I'll be posting a link to purchase Fear of a Black Universe on harvard.com, as well as a link to donate in support of this series and our store. Your purchases and financial contributions make events like tonight's possible and help ensure the future of a landmark independent bookstore. Thank you to our partners at Harvard University, and thank you all for showing up and tuning in support of authors, publishers, indie bookselling, and especially for science, because it really, really does matter. And finally, as you may have experienced in virtual gatherings this past year, technical issues may arise. If they do, we'll do our best to resolve them as quickly as possible. Thank you so much for your patience and understanding. Now it's my pleasure to turn things over to our Harvard Science faculty colleague and theoretical physicist, Greg Keston, who will introduce this evening's authors. The digital podium is all yours, Greg.
Great. Thank you, Benjamin. Well, I am honored to introduce tonight's speakers. Stephon Alexander is a professor of theoretical physics at Brown University, an established jazz musician, and an immigrant from Trinidad who grew up in the Bronx. He's the 2020 president of the National Society of Black Physicists and a founding director of Brown University's Presidential Scholar Program, which supports research and academic excellence for underrepresented students. And in addition to his academic achievements, he was the scientific consultant for Ava DuVernay for the feature film A Wrinkle in Time, and his work's been featured in the New York Times, Wall Street Journal, Wired, many other outlets. He's been a guest on Nova, The Brian Lehrer Show, Neil deGrasse Tyson's Star Talk, and many more. And joining him in conversation will be Brandon Ogbunu, who is an assistant professor in the Department of Ecology and Evolutionary Biology at Yale. And his work utilizes a range of methods from experimental evolution to biochemistry, applied mathematics, evolutionary computation, and is all geared toward a refined understanding of complex systems and disease phenomena. And he runs a parallel research program at the intersection of science, society, and culture. And in that capacity, he explores technical questions about the role of society and culture in complex biological phenomena. In addition, he writes, gives public lectures, and creates media of all kinds. And he's a contributing editor at Radiolab, an ideas contributor at Wired, and has written for a range of publications, including Scientific American, The Undefeated, Undark, Boston Review, and several other various topics at the intersection of science and society. And tonight, they'll be discussing Stephon's latest book, Fear of a Black Universe, an outsider's guide to the future of physics. As Edward Frankel says, this book explores some of the biggest mysteries of all: dark matter, dark energy, origin of the universe, origin of life, and in ways that are unconventional and enthralling, yet down to earth. Jaron Lanier says this book revives the humanist project that launched science in the first place. And I think DJ Spooky put it most concisely when he said, this book will blow your mind. So be prepared and enjoy. Stephon, Brandon, take it away.
Thanks, Greg.
Thank you so much, Greg. Thank you so much for to everyone involved, all of the sponsors, the Harvard Bookstore, the Harvard Science book series. Really, my privilege to be here to have a conversation with my dear friend and colleague on the event of the publication of this exciting new text. What's going on, beloved? How are you?
I'm doing great, man. It's great to be on the stage with you, and a real honor to be hosted by the Harvard Bookstore. I mean, both of you and I, we have, since we were youngins, back when I was a grad student 20 years ago or something, I used to go up to Cambridge and, walk into that bookstore dreaming of being able to buy books. And I'm just kidding. So,
yeah. No, definitely. There's a meta thing going on with me and you being able to have this conversation in this setting. So nonetheless, let's get it going. So congratulations, Professor, on the publication of your new book. And there's so many things, there's so many gems. It's packed with all of these provocative ideas. Of course, I would expect no less coming from you. You know what I'm saying? So we're going to dive right into a few of them. And then, of course, we'll take that and we'll meander through the infinite space of kind of the interesting corners of your mind. And that's what we'll be doing over the next 40 minutes or so. We have to start with your use of the way you title your books. Okay, so we'll go back to the Jazz of Physics. And of course, that was elegantly titled, and what a beautiful kind of set of ideas were contained there, and the way you drew these parallels between jazz as a concept and meta concept and the work that goes on in your laboratory. And for the second book, I guess you wanted to go conservative. So you chose this sphere of a Black universe, and of course made this appeal to the outsiders. So walk us through kind of that process through which you how you just came up with that title. And in particular, right, what's fascinating is your multiple meanings behind the word Black in that.
Mm-hmm. Well, yeah. You actually get into the hardest questions first to take. It seems I should expect no less from you. Well, I mean, full disclosure, Brandon and I, we've known each other for more than like 15 years now. When you were an MD PhD student at Yale, and we're both returned to become professors at the very places that we did our PhD. That's uncanny usually. I think you're the only colleague I know of your generation that did that. Anyway, so that's an interesting point of departure. So let's see. The title, in this book, I did things. It was an opportunity for me to give myself permission through the lens of this book to do things and play with things that I didn't do before, both intellectually and personally. So one thing as you know me very well, I really suck at being sarcastic. In fact, I'm oftentimes criticized or made fun of by close friends and family that I sometimes can't even take a joke, sarcasm. Sometimes I take literally because I myself have a hard time being sarcastic. Can be very direct to my own demise sometimes. I know people say that. I know you guys make fun of me, and I know things that y'all say about me. But anyway, to make a long story short, my publisher and especially my editor, T.J. Kelleher, who is the best, and I mean this very seriously, I think the best science editor known on the planet, and at least in this planet. So very fortunate to have had him edit both Fear of a Black Universe and what's the other, The Jazz of Physics. And so anyway, so what's the title of the book going to be? What are you thinking about? Months would go, and I kept coming up with titles, and the titles are all corny, So the titles are all corny, and I was just like, okay, I gotta keep going. I gotta keep trying, you know. Now, one interesting thing about TJ is a Harvard alum, and I believe that he was the editor of one of the student newspapers, which I'm forgetting. And I decided, hey, this will be fun. Let me get TJ. I'm going to invite TJ to give some lectures at Brown and engage other faculty. I think you met TJ, but it was deliberate because I wanted to get him out to Brown so I can have time alone with him. And I decided to take him to this Irish pub, right? You know, and basically try to convince him that, you know, of talk with him about the proper title. And I was getting nowhere. Now it's like 2 o'clock in the morning. I'm like, no title is working. So I decided, after a couple of brews, I decided to get sarcastic. And I said, you know what? I think I got the title of the book, TJ, and it was complete sarcasm. I said, Fear of a Black Universe. And I started
in
laughing.
that voice, you said it like that. You said it just like that, I know.
Yeah, exactly. I was like, Fear of a Black Universe. So anyway, fast forward about a month later, it was a joke. TJ texts me or he calls me, he goes, that's it. I spoke to the people, like the people at Basic, and they love that title. And in my head, I was like, really? These bow tie wearing cats and 55th, whatever, Park Avenue, whatever, they like that title? That's really funny. I was like, I had like a moment there. And then the more I started thinking about it, I was like, and then of course I remember you were there from the get-go when I started to write this book. In fact, full disclosure, Brandon was the very first person I gave when I had the mad idea that I was going to write this book. I gave a draft, a very bad draft, an inchoate draft of the proposal of this book. Actually, you were the first person to look at that. So I remember when anyway, so that's. But then it turned out it was one of these things, and I want to jump back to hear your thoughts about this. But then the more I thought about it, and more I thought about this, I realized actually it was one of these subconscious things. It had to be the title, okay? Mm-hmm. And then, as you know, when we start thinking about quantum mechanics, the dualities or the superposition, like the idea that a concept can have many meanings. And I know in literature, there's some device where you can have an ambiguity in the title. And again, it's not something I'm sophisticated about. But it turned out the idea that there's this ambiguity in the title also had some interesting overtones.
Mm-hmm. Great. No. And let's, and we're not going to give away, because of course, that's the challenge of this. There's so many gems in this book that I want to reveal. It's almost like the reveal in a movie. You can't give too much away. But I think the book does this excellent job of talking about kind of, the Black universe, right? You're talking about some specific things. So you're talking about these ideas related to your personal life, and you're talking about some ideas related to the physics that you do, related to physics that you do. So can you comment briefly on that specific duality?
Yeah. Let me first get to the, in some ways, and some of the things that's really funny about the book is that every now and then, like for other podcasts I've done, you'll have like some person who never read the book or doesn't, and they'll just, I'm tired of hearing about critical race theory and, these types of things. And I'm like, that's interesting because really and truly, when I was in college, I have pictures where I used to rock African medallions and I was listening nonstop to Public Enemy. And one of the albums that really influenced me was Fear of a Black Planet, by Public Enemy. And I remember I used to be walking down campus and there was a lyric in that. And that lyric really captured a lot of, a lot of my journey as a scientist, as a physicist, and like the challenges that I face intellectually, personally, and all these things. And that lyric was, I got so much trouble on my mind, refuse to lose, here's your ticket. Here the journal, whatever. But that line, I remember I used to that was my mantra, where Chuck D would say, I got so much trouble in my mind, refuse to lose. And like the refuse to lose had to do with that striving for excellence. And another way was Joe Henderson, the great one of my favorite jazz sax players. He had a song that all sax players, like giant steps, if you a rite of passage, you got to go through called Inner Urge. Same thing. You got to dig deep and strive for that excellence in the face of challenges that you might be going, and in the face of the fact that expectations may not exist for you as you know, a Black man or a Black person, a Black scientist. So for me, part of that was a nod to Public Enemy and how much it sort of what that meant to me as a young student, and also how that influenced me throughout. And then the second, I would say, resonance that that title had was about the category of Blackness, and the category of Blackness in general, like, and you know, in America, that plays itself out as stigma. And, you know, as Black people, you know, we have to deal with stigma. We have to deal with threat, being a threat, and all these things, right? And for me, that's a reality, you know, people grabbing their purses in the elevator and crossing the street when they walk, all these things, right? And the book was really about, like, sort of, but also the category of Blackness in terms of ideas. That you can, as a scientist, you can generate ideas in the name of research, in the name of breaking new ground that may stigmatize you, that may kick you out of the club, so to speak, because you're not necessarily following the herd. And that's not in terms of being defiant, but in terms of that, if you're generally trying to, you know, do something, and you know, and the book was also exploring that with other great breakthroughs in physics, like people like Michael Faraday and Albert Einstein and Schrodinger, and also realizing they themselves had to navigate that as well. So it was about that idea of how to embrace that outsider status that comes with sometimes the risk of generating such ideas, Black ideas, and yeah. So that's the second intonation.
Nah, I mean, what a thank you for that. I think, you know, I think that's the thing that jumps out at us when we see it on the bookshelf. It's like, okay, what we going to get into here?
I have a question for you.
Yeah.
How did it jump out at you when you saw that title?
You know, I think, well, I mean, I think knowing the way you think about things, I knew there was going to be some depth there. And, you know, I think this is kind of related to the next, you know, set of things I want to talk to you about, which is what I especially, this is why I knew, this is what I knew when you had that title. Number one, I loved it because I love Public Enemy, and that I think people have lost sight of what that era was like. You know what I'm saying? People forget they were a mega popular group that was selling out the Garden. This wasn't like an underground, you know what I mean? Like that rap, they were a defining group of the whole culture. You know what I'm saying? And I think hip hop culture changed for reasons we'll get into during our next conversation. But my point is, I think to resurrect that and invoke that in the context of the theoretical cosmological questions that you think about was beautiful. But I think what gets me about you, one of the reasons why you're so inspiring to me and to many is, frankly, you could be just like a lot of people who are unique in your field or are alone in your field, like a lot of Black scientists, and talk about how hard you had it, and do a woe is me story about how you had all the hardships of anybody that I know. You know what I'm saying? But what you do in your work consistently is you always offer original physics ideas. You never let anybody get by on just your identity. You're always pushing the envelope, you know? And so in light of that, I want to talk about some of the ideas that you're working on, and some of which are, you know, featured in the book. And Jazz of Physics did that beautifully. I mean, you have literally taken concepts from, you know, harmony and worked them into cosmological things and published the papers. This is not like a joke. You actually have done this. So maybe even mention a couple of the ideas that you kind of mention in the book, kind of fitting within this Black universe framework that excites you.
Very good. Well, you know, but thank you, first of all. I'm you know, really, sometimes it's hard for me to take, anyway.
Man, it ain't hard for you to take compliments, man. Whatever. Don't be, you know, don't act humble. Don't let these fancy people
call me out right here.
Let me tell you something. We having a conversation. Ignore these fancy people. This is me and you.
All right, bro. Okay. Say no more. Yeah, I think that. Yeah, that well, I think that one thing I'm really excited about these days, I wasn't at first, but there's a little story behind that. So when I was a junior professor, when I say junior professor, I was when I started out, I was a professor at Penn State. And no, I'm sorry, no, I went to Dartmouth. This is when I was at Dartmouth. I decided that I was going to drive to New York, but on a whim, I decided I was going to take a pit stop and pass by Providence and visit my old one of my advisors. So I started off with a PhD advisor, and I switched into cosmology. But this person has always remained close to me, and I've always been in touch with all throughout my career. And this is Leon Cooper, who won the Nobel Prize for conductivity. And he, you know, is a New Yorker like us, and he doesn't mince his words. And he solved he's my hero, okay? Actually, I have in my living room a picture of Leon right now. In fact, I'm just gonna show it off. I'm gonna show it off.
Why you been?
Yeah,
I thought you was modest, and now you're showing off your fly apartment.
That's a picture of Leon Cooper.
Nice.
I had that done by a great watercolorist, William Haidt from Newport. Commissioned that. Anyway, so make a long story short, I decided to pass by, and the reason why is because I wanted to finally impress him. You see, because I was never able to impress Leon, right? Never able to impress him. I felt like, okay, I just got this fancy award and all this stuff. I got a big grant, and I just got tenure too, you know? So I said, let me drive down and pop in. And he was in his office, and, you know, right about to retire, actually. And so like, you know, a little quick background. Leon solved the problem that was almost 50 years old that Einstein worked on, Feynman worked on this problem, Landau, all the greats worked on this problem, right? Superconductivity. And he cracked this problem, okay, theoretically. And I'm in his office now, and I'm like, hey, Leon, you know, I'm working on this really interesting problem, and I keep going off. And he goes, you know what, Stephon, can you slow down? I was like, he goes, you know, I think I'm a pretty smart, okay guy, you know, but you need to slow down. And in fact, and he goes on this thing and goes, you know what you need to do? You need to find a real problem and work on a real problem, okay? You know, people are afraid of working on hard problems because they're told it's impossible. And I think that people are not working hard enough. And he just kept going off on me. And at that moment, my interpretation, I was flattered that he was challenging me to that level. Instead of me taking that as, oh, this guy's like, you know, calling me dumb and like, you know, he's projecting, da, da, da. I took that as he thinks Leon really respects my intellect so much that he is basically challenging me to pick the hardest problems, the problems that appear to be impossible, and try to solve them. And then he goes on a blackboard, he goes, you know, like, for example, you know, when people think about the Big Bang singularity, they say that it's impossible to solve, but he has a little trick, and he goes on a blackboard and he does this little like cats from the hood, like, you know, that playing the dozens, or they got some trick under this. Right. To the trade. Yeah. Yep. And like, you know, it's like, you know, like one of these like little tricks, a card trick almost. And he goes on a board, and as he's doing this, I'm like, wait a minute, that's actually really interesting. So then a few years go by, and it turned out that thing that he was telling me, I was able to, that became a part of this, of the kernel of some ideas surrounding basically the following paradox. We think that quantum mechanics is something that operates on the microscopic scale, atomic and subatomic scale. And there's some cases in condensed matter systems, like, you know, metals and, you know, superconductors and superfluids where quantum mechanics can, but when we start talking about on scales of buildings and planets and things like that, you know, the world is classical. Quantum mechanical effects get washed out. And this idea is basically claims that at the scale of galaxies, quantum mechanics reappears like a phoenix. And in fact, it's these quantum properties that are responsible for the phenomenon of dark matter. And so there's a chapter in a book called Quantum Galaxies. And this is an idea that I developed along with my postdoc, Evan McDonough, who's now a junior faculty, and my mentor and collaborator, David Spergel. And that idea basically thinks about dark matter, which is about 85% of the matter in our galaxy, for example, that's invisible. We have indirect ways of measuring this thing independently. But basically, the theoretical idea is that this dark matter is actually some sort of quantum effect, okay? That's very similar to a superfluid. And that idea, you know, again, it happened simultaneously by some other colleagues, you know, Justin Curry and Ronald Mallet and Silverman and others. But anyway, that's one idea that I'm excited about, and we're working on developing that theory and ways of observationally testing that idea from to distinguish it from other forms of dark matter.
I mean, wow, you know, fascinating. I think, and I think big and bold, like a lot of the questions that you ask. I mean, you know, and, you know, we've talked about quantum, you know, systems in biology, and there are these other kind of examples of it popping up all over the universe. In relation to that, then while we stay on science for a minute, right? I mean, we're going to stay on science the whole time, but why don't we stay firmly on some of the ideas? I think some of the stuff you talk about in the book, I know you've had this fascination with the institution, right? But the thing that we talk about, life.
Yes.
We talk about life a lot. And I think, you know, we're both fans of, you know, Schrodinger's What is Life? I think we've kind of read it and interpreted it different ways. And we've had our set of arguments, you know, in conversations about what that is. And I think now there's all of these cutting edge ideas. I'm one of those physicist friendly biologists. I think I'm quantitative amongst biologists, not quite around you all. And this question about what life is life just an accumulation of interesting physics that we have not yet resolved? Can we recapitulate life through kind of the set of discrete physics in these different entities that we've identified? Or is there something yet it's not unlike the consciousness problem in some ways, right? There's some analogies between those two. So I want to hear where you're landing on living things and what life is, and maybe where it came from, and then hopefully me and you can argue for the rest of the time.
Well, you know, this conversation also is one of the things that our friendship is based on. Like, you know, me, you, and also we have a mutual friend and your colleague and collaborator, Professor Salvador Almagro Moreno, who you know, many you know, glasses of wine kind of types of conversation that, as you know, you're a physics friendly biologist, but I'm a biology friendly physicist. And in fact, an interloper, right? And so the book is also about, you know, me giving myself permission to also be an interloper and basically jump into other people's fields and speculate in the spirit of what Schrodinger did. Of course, Schrodinger did it much better than I did it, because after he won the Nobel Prize for his work in quantum mechanics and co-pioneering quantum mechanics, he started asking the question, how is it that, you know, that if quantum mechanics is operating at the most fundamental level of understanding the nature of the physical world, and could explain chemistry and could explain, you know, molecules, all those things, therefore it explains non-living matter very well. So how could the laws of physics, including quantum mechanics, actually, you know, account for life and say something about life? And then he used that to make some predictions, which, as you know better than me, was played a key role in the discovery of DNA. But he left us in that book, What is Life, with some puzzles. And I decided in this book to take up some of these puzzles and do my own sort of interloping as a physicist, using some of the more modern things that we now know since Schrodinger's time when he wrote that book, which was in the 40s. And, you know, so we have learned some things from the 40s in physics and modern physics, quantum field theory, you know, approaches to quantum ways of thinking about how to unite quantum mechanics and gravity. And so I decided to play some games here. And so one of the things that I speculated on was the following crazy thought. in cosmology, which is my home field, one of the things that we know and was predicted and turned out to experimentally be confirmed, Einstein, in a nutshell, tell us that space and time and the properties of gravity, such as a gravitational force, is just basically a manifestation of curved space and time. And one of the things that space and time can do is actually, when we look at the entire space-time of our universe, is that it expands, and we can observe that effect of an expanded space-time. And I remember as a student, when I learned that, and this is actually part of one of the things I really wanted to do was empower people reading this book, because there are things that I remember learning as a student that I felt dumb that I didn't understand it because it was so basic. And it turns out that some of these basic questions were actually fundamental questions. We learn F is equal to MA, but if students don't, I tell my students, if you don't understand it, if you don't understand that concept, it's probably because you're much smarter than what I'm teaching you right now.
Mhm.
So one of the questions I asked as a student was, why should we care that the universe is expanding? If it's expanding, what does that mean? What is the purpose of that, right? It's expanding. So what? We don't see that the effects of expansion right now.
Right. I'm not
So one of the
expanding
things-
right now.
yeah.
We just
So in a nutshell, what I did in this book was to basically link the expansion of the universe and the rate, meaning how fast the universe is expanding, with basically the conditions for the occurrence, or one of the conditions for the occurrence of life on Earth. In other words, when we think about like the conditions for life on Earth, one of the things that we say the Earth needs is a biosphere. And maybe I'm going to pause and maybe you can say a few words much better than me about how you think about the biosphere.
Well, I mean, I think, we have limited access to kind of what are the range of environmental conditions in which we see life operating, in which DNA-based life, if you will, or are operating. And I think that those are kind of the physical limits of our imagination at the moment. But fields like geology have expanded some of that. And I think right now I would ground the biosphere in terms of things that we can measure geologically, thermodynamically.
Yes.
And there's a large breadth of environments in which in which life can exist. I think feels like astrobiology,
Yes.
or exobiology are really interested in kind of, all right, well, what are the other, can those conditions that we can imagine, are they present in other planets, like in our proximity, to the extent whereby they might be candidates either for life that already exists or future life that can be colonized. So that's how I would think about it.
Right. So there are certain necessary things that life needs, basically, biological life is need, and our planet provides the right environment. And one, as you know, and as you know, much better than me, there are lots of factors, and it's very nonlinear and very interconnected, and as you said, highly networked.
Mm-hmm.
But one of the major ones that the cosmologists that I paid attention to was energy. We need energy, and you have a theory I know of free energy that I know you've been developing. And one of the ideas here is that our sun needs to provide exactly the right amount and flux of energy to sustain basically plant life, and then biologically, how that feeds off and sustains other life forms on Earth in this biosphere, right? But it turns out that there's a mystery in cosmology that we still don't have a solution to this problem. And so oftentimes in physics, we look at complicated phenomena, and the job I find of a good physicist is to dumb things down. Actually, it's to take this range of very complicated and what may appear to be unrelated phenomena and distill it down to a very simple sets of principles and ideas. So there's an economy of being able, of taking a simple idea and using that idea to generate whatever. Newton's law is an example of that. And the idea here was is there a lens through which I can look at the universe and the processes of the universe that could say something about the occurrence of life? And it turned out, what I found, it had to do with that the lens had to do with the currency of entropy, that the universe is basically, as it expands, the expansion rate of the universe controls the way entropy flows from larger scale systems, like from galaxies to stars, then from stars to planet. And somehow the way that that entropy, which is life, has to fight against this tendency to disorder, to basically disrupting the structure that life needs to sustain throughout the lifetime of the organism. That very thing that's happening with our own bodies right now, that we need to basically always fight against disorder by taking in free energy. That currency, that flow of negative entropy, is something that the universe is doing from larger scale to smaller scale. And that is controlled actually by the expansion rate. So there's this cosmic sort of relationship, which is the expansion rate, to the micro, which is, you think about the universe as in its entirety, millions of parsecs in distance scales, to basically, the solar system, which is minuscule compared to that scale. So anyway, that was, again, that I go into a lot of details.
No. That's really trippy. I know the origin of life stuff, and I know the, and connecting that to big ideas like the expansion are really cool. And we're coming up on the time soon where we, me and you we can do this for hours and hours, brother, that. I'm going to ask one last question and cover one last thing, and then we'll kind of get into the questions and conversation, hopefully with the individuals in attendance. And one of the things I want to talk about, you have this excellent chapter, what if Basquiat was a physicist? And I'll leave the audience to read that for themselves, what's in it. But I think one of the things about you, and I think people make the mistake of thinking you're a cool guy, when in fact, you're a huge dork. And I think that's one of the things that we, us city boys, get away with for people who don't know any better. But I think what I want to go back is to your past, to the way you were raised. And I think what's really interesting about it is talk to us about how the line between being cool and accessible and being working on highfalutin and complicated ideas. You've never really seen a conflict between those things. You've never, the way they kind of articulate in grade school that you have to be in one camp or another. These things are all folded into your culture. So maybe you want to explain that concept to us. Walk us through that.
Yeah. So, as you know, my family immigrated from Trinidad and Tobago, two separate islands, to the Bronx. And since I was 8 years old, I grew up in the Bronx. And I would say, this was during the 80s. And so, a lot of what was going on with the development of hip hop culture was happening right in the neighborhood. And, one of the elements in that culture was knowledge, what we call knowledge. And we know that you and I were highly influenced by the 5 percenters. And that was very impactful. A lot of the most influential and popular and famous and cool rappers were all either 5 percenters or highly influenced by that. And so for me, being cool, was never, let's see the best way to say this. The best way to say is maybe through a quick story. I used to take the 30 bus from my neighborhood to my high school, DeWitt Clinton High School. And back then I used to work on my calculus homework. I was taking calculus at a neighboring college. I think it was my junior year. And I'm in the bus do my calculus homework. And all sorts of characters are walking through that bus, including some not too friendly characters. But the 5 percenters would also be on that bus. And they would be, dropping their knowledge and that kind of stuff. And they would take notice of me doing my homework. And they would basically, from time to time, they would engage me. Like, man, what's up with that, man? What's that knowledge there, man? I'm doing I'm studying derivatives, man, and integration. And be like, man, that's the next level. This guy's doing supreme mathematics kind of stuff, right? And they basically protected me. They treated me as one of, I never joined the 5 percent, but I was basically part of the crew, so to speak. They literally kind of celebrated that. Right. So these were the guys that, you didn't want to really mess with these guys. But at the same time, and I was actually part of a crew. I was part of a rap group where I was kind of nerding out on digital samplers and things like that. And when it was time for me to go to college, these guys were about to sign a record deal and with Africa Bambaataa. And they told me that I should go to college. It was like, yo, you need to go to college, man, and come get that knowledge and come back. So again, it was never, and I think you would agree too, like this idea of being cool and being smart and like seeking knowledge. And, they were never paradoxical growing up in the Bronx. And that was never a paradox. Now the media portrayed that differently, right? But that was not the case in the neighborhood.
Yeah, I mean, I think the media, just slandered our culture in a lot of ways in that generation.
Yeah.
You know what I'm saying?
Yeah, I got an axe to grind about that.
Made it seem anti-intellectual. And I'm gonna tell you right now, in our community, the toughest dudes were the smart ones and had the knowledge. That was a part of the dimension. You know what I'm saying? So, that
remember they used to come around. They would come around with their books and be like, so what's the knowledge, right?
Yeah, exactly. So I think that's just something I see very present in your work, the way you're able to connect with people and why you're so relatable to a lot of people. And I congratulate you for it. If you can believe it, we're at the point in the conversation, man, we're supposed to be answering questions. You know what I'm saying? I know me and you don't get, me and you, we can get carried away and we'll start, it'll be like on the block.
I just want to give love to some of my, to Rakim.
No doubt.
Right. And Nas and Chuck D, who really supported my book. And
it's funny, people.
And Universal Hip Hop Museum.
It's funny, man. People don't understand. Those are like our intellectual heroes. You know what I'm saying? People think it's a joke. That's who we are. That's when we're writing manuscripts. That's who we're inspired by. So we're gonna go to some questions from the audience, if that's okay. Bunch of very, very interesting ones. This one from Nathaniel Schwartz. Question: any thoughts on possible applications of George Russell's Lydian chromatic concept of tonal organizations?
Mm-hmm.
Right. Yeah, apparently, this had a big influence on Train and Miles, epitomized by the respective 1959 releases Blue Train and Kinda Blue. Could chord modes outlined by Russell serve as a harmonic analog to the different vibrational modes in string theory that produce different types of subatomic particles? Woo!
Yeah. So that's a very good question. In a nutshell, George Russell is, is a theorist and a jazz pianist, and he wrote this very deep book, and that did influence the likes of Coltrane and also Joe Henderson, who I'm a student of Joe Henderson's music. So in a nutshell, when we look at the resonance of a string, for example, and I vibrate the string, I can generate overtones, right? So all I really mean by that is that I'll get like a fundamental vibration, and then the other vibrations are corresponds to waves that differ, whose frequency differ by integer values. And when I get to the third harmonic, that's a perfect fifth. And like, so for example, C, it'll be G would be the perfect fifth. Mm-hmm. So ba ba ba, that's a big interval that's very consonant. In a nutshell, Russell basically shows that if you revisit the major scale as the most, as you said, the brightest scale, right? The most, major versus minor. It's not quite the major. In the key of C major, right? Do, re, mi, fa, sol, la, ti, do. The F becomes F sharp. It becomes, and that's a Lydian scale. That's a Lydian mode. So yes, it's a very deep concept based on the natural vibrations, and you generate scales that way. And it's something these days actually, coincidentally talking to some jazz musicians about. Yeah, thanks for asking that question.
And look at that, the way you're able to move from, quantum galaxies and you singing tunes to us. I mean, this is just Black excellence, man. I'm very, very proud, brother. To the next question.
Trying to be like you, man.
Man, whatever, man. Don't even try. We're not doing that. And speaking of Black excellence, we got the great Chris Rose, Professor Chris Rose.
Yo, get him off. That guy scares me too much, man. He's gonna ask me a hard question.
No. This is a very relevant and germane, and I think fascinating question. Can you comment on fear of a Black universe in the context of Black scientists and engineers gathering at forward-thinking institutions to produce profound conceptual breakthroughs a sort of jazz? That is, might this sort of Black critical mass engender yet more fear of a Black universe?
Well, one of the things that, and I'm not saying this because, okay, I admire the man, and he's, and he actually was the person that recruited me to Brown University. I'm just going to call him out that way. One of the most brilliant theorists out.
We call him. Go
Yeah,
ahead.
he's a homeboy.
We call him Nick Fury.
Yeah,
He's the Nick Fury.
Anyway, yeah. So this question actually. Yeah, so there is the unspeakable in this book, and it's one of the things that, in fact, if we go to Fear of a Black Planet, this and listen to some of the lyrics, some of that fear actually had to do with the idea that the population might get to a place where we start outnumbering people, and all of a sudden, what was once, if I'm the only Black person in the room, maybe you're cool with me, and there's a little bit of tokenism, and you're cool. But start bringing 50 of us in the room now, and we're all really, producing at some, and start making breakthroughs. How does, yes? So the answer is yes, yes, yes. I mean, one of the things I was wrestling with in this book was some of the experiences I had was, in spaces, and I talk a little bit about this, and not only about myself, but other Black scientists, is that when we started really breaking new ground and solving problems and approaching things in a completely different way, like how jazz was invented, right? And, Chris founded something at Brown called STEM Jazz, which basically brings together and Black and Latino scholars in STEM to collaborate together, and our colleagues. And the question here is that what starts happening when we actually start outperforming in a way that we are not expected to? Does that incite fear, right? A different kind of fear. And yes, I think that my writing the book was in this way was, this book is 90% a book about really exploring the biggest and the deepest ideas and speculating on these deepest ideas, and with the idea that maybe I might accidentally hit on a solution to these problems, but I also need to go there. And if I did that, would that scare people off? So yeah, there's a lot there, Chris, and a lot for us to continue talking about. Yes, and I really resonate with that. I'm not doing justice to that question, by the way.
No, I mean, it's one, like you said, it's one thing when it's one person doing something. I think, I think what's interesting is when it becomes groups of people that aren't supposed to be there doing it, it becomes uncomfortable even to people who think that they are pro diversity. Yeah, I've seen that happen. I've seen
absolutely. I mean, if you look at bebop jazz, right? I mean? They wanted to, the inventors of bebop jazz wanted to take swing, wanted to take that music to a higher level. They wanted to be higher art. And they wanted to experiment and take it to this other intellectual level as well as artistic level. And yeah, I mean, we're trying to do the same thing in the sciences days, No,
excellent. It's a question. This is a lovely question from how can I join? Someone asked, I don't want to mispronounce the name. How can I join the rooms that, I don't have my glasses, so how can I join the rooms that you both are in, and of the way you both break down complex knowledge, wisdom, and understanding related to culture, science, and still fluid with experiences with what's considered edge. So, that's not me. That's for you, Professor. But thank you for the question. Any answer how to join the rooms we're in? How do you get into these conversations?
Well, one thing you can do is read
the book.
You can read the book for sure. You can come down to Yale or Brown and sit in a class, or you could, there are certain organizations that are welcoming. You don't have to be Black to join them. The National Society of Black Physicists, anyone can join NSBP. And there are lots of opportunities there to kind of be in the room with us and others like us and be a part of that. So, we're very welcoming of, yeah.
No doubt. That's part of the culture. I mean, we really want to, it's as pro our own communities we are. The point is for everybody to elevate everybody. And that's the Black experience as I see it.
Yeah, so, we love to shoot the dozens and engage in dialogue.
In dialogue, with everybody, elevation and opening doors. Great question here. was there anything that surprised you while you worked on the book? This is a question I was going to ask you. Anything that surprised you that you came up with while you was working on this project?
Oh yeah, that's a tough. That's a tough one. Yes, I mean there were things that surprised me, like the direction that the book took. I wrote this book going into it not really being clear about what the book was actually going to be about, to be honest. And then many of us, I see that one of my heroes, at least was on this thing earlier on, who is a tremendous, amongst other things, scholar and writer, who was at Harvard. I won't call his name out. And he, one of the things that, devices that I realize is that you write a book to actually, the writing of the book itself is going to actually teach you new things. So I think one of the things that surprised me in writing the book was that it actually did help me clarify some of the research directions that I'm undertaking now in my own research. And yeah.
That's a great, that's a great point. So the process itself was generative, and I think, that's the way, of course, biological evolution works, right? The process of adaptation takes you to kind of new spaces of biological design space, which then opened up new doors. So I like that analogy to the creative process, and certainly jazz works that way as a music.
There was a lot of improvisational writing in the second half.
A lot of improvisational writing. Now, a lot of people in the audience, man, I want to acknowledge some good questions left. Any darlings that landed on the cutting room floor while you were putting the book together that you'd like to tell us about? Any darlings, maybe with regards to titles or ideas or things that didn't make the book that, you're like, or
that's
something.
a good question.
Yeah.
There was, well, I think that one thing exactly, Chris Rose's question, like that other dimension of fear that, of basically Black excellence, and also saying that we are in these spaces, at these intellectual spaces, because we want to play, we want to excel. We're going to excel. But the idea of like doing it, also mastering the skills and the chops to then jazz it up and do it the way we do it. It was, again, it was something that I wish I would have put more bandwidth into in writing a book, but I think the story continues, and maybe that's for someone else to write.
That's gonna be the third book. You know what I'm saying?
I think I'm done.
Yo, shout out Dr. Yitbark, my man Sinai asked the question. He's here. What's going on, brother? Good to see you here. If I had a chance to drink a beer in an Irish pub with the esteemed Dr. Alexander, will leave me out of that. The first question I would ask is whether the universe is discrete or continuous. My other question is how the hip hop group A Tribe Called Quest influenced your appreciation of jazz music? That's interesting. That's a separate question. But discrete or continuous universe?
I'd say it's both. And it's a question that we have not resolved yet. And it's actually a question, literally, there was a seminar today from MIT that we had today at Brown, where they were literally talking about discrete structures and quantum field theory and how that's related to continuous, and some interest in anomalies and puzzles. So yeah, it's a very good question, but I would say that it's neither nor, but it's both. My colleague, Professor Gates, and mentor, works on structures having to do with supersymmetry that smells something like that as well. And Professor Rose, actually, in terms of information theory and communication theory, we actually coincidentally are actually in conversation right now about, I would say at a store, at a theater near you or something like that. We're working on it.
So if you can believe it, we're out of time.
Tribe Called Quest, though, yeah, big time. Tribe Called Quest is big time.
Oh yeah, Tribe is
the lyricism.
Tribe was church to me. You know what I'm saying? The
continuation of that bebop tradition into hip hop is kind of what they, amongst other things, right?
That type of interloping is what we do scientifically. You know what I'm saying? So we're out of time, believe it or not. We got 1 minute left. I want to acknowledge the sponsors again. A lot of great people in the audience. Dr. Osman, Dr. Hinton. You know what I'm saying? Paul,
all right.
You know what I mean?
That's
all that, you know what I'm saying? Dr. Yitbark, all these people, oh man, Tisa is in the building, my agent, all that. So thank you all for coming. Brother Professor, thank you for offering your thoughts and your conceptions here and sharing them with me and the audience. And with that, take it away.
All right, Brother Ogbunu, thank you. Thank you, Professor Ogbunu. always wanted to say that publicly, the day you become a professor. And much love, and yeah, don't try to box me out here, bro. You got to coach me one of these days, man.
You got it.
Yeah.
Say the word.
All right, bro.
Okay, well, thank you both for this fantastic presentation, and thank you to Greg again for his wonderful introduction. Thanks to all of you out there for spending part of your evening with us. Please learn more about this fascinating book and purchase Fear of a Black Universe at harvard.com. On behalf of Harvard Bookstore, the Harvard Division of Science, and the Harvard Library, all here in Cambridge, Massachusetts, have a good night, keep reading, and be well. Thanks again, everyone.